Hello class, welcome to our lesson today dealing with section 3.4. This deals with what is known as measures of relative standing, and so we're going to look at some introduction pieces to that. There's also something called a box plot, that actually probably be in the next lesson, but that also talks about relative standing. So the whole point of relative standing is how do you compare to kind of other data points or another group or something like that. And so that's what we're going to start with here, with what's known as a z-score. Now, we're going to be talking a lot about z-scores over the next couple months. So, z-scores are found by converting whatever data you have into some standardized unit so that no matter what data we're looking at, we only need one chart or one table or one way of solving things. And so, by definition, a z-score is the number of standard deviations away from the mean that a data point is. And so, to find that, it's just a formula. And it's always going to be your data point. So, x is a data point. So, x here is the same for population or sample. Okay, so it's your data point minus the average or the mean, so x bar for a sample mean, mu for a population mean, and then divided by the standard deviation. And so what you're really doing is finding the difference, how far away are you from average, and then saying, well, what's the standard unit of variation, which is standard deviation, and divide that out. So these two formulas are really the same thing. It's just one's for a sample and one's for a population. One note that you want to look at for z-scores is because of some tables we're going to be looking at later on, you're going to round z-scores always to 2 decimal points, no matter what the situation, so always 2 places. I know in other cases you round to different spots depending on the question. But in general, z-scores are always rounded to 2 places, and you'll see that why as we move through the chapters. What's cool about z-scores is once we get everything converted to what's known as a z-score, we can tell if something's ordinary or unusual by the 2 standard deviation approach. So the idea is if you're within 2 standard deviations, which is from -2 to 2, the z-score is how many standard deviations away you are from average. And so if you're within that realm of -2 to 2, that's not an unusual data point. However, if your number is less than -2, you're unusually low, or if you're larger than 2, you're unusually high compared to the rest of the data. Okay, so when interpreting, a z-score of less than 2, within 2, is going to be usual, and if it's outside that realm from -2 further down or 2 further up, then that would be considered an unusual data point. So this says the average score on last year's final exam was 75.4%, standard deviation of 4.7%. Find the minimum and maximum usual values. Well, that can be found by taking the mean plus or minus 2 standard deviations. So the mean plus or minus 2 of the standard deviations. If I take 75.4 minus 2 times 4.7, I get 66. And do the same thing with plus, I get 84.8. So any point within that realm is going to be considered a usual number. And so this says find the z-score for a student who got a 90%. So first thing to notice is we already know that's going to be unusual because the information we found above. Is 90 within that realm from 66 to 84.8? And the answer is no. So that's an unusual data point. Okay, that's unusual. The z-score would be found by taking my data point, which is 90, minus the mean 75.4, divided by 4.7. Make sure whatever calculator you're using, you know how to plug this in, and you should get an answer of 3.11 rounded to the nearest hundredth. And again, that's also a way to show it's unusual because it's more than 2. What that's saying is I'm 3.11 standard deviations above average. And our general rule of 2 standard deviations, that would be considered an unusual data point. Outside of z-scores, the other thing we need to look at is what are known as percentiles. Okay, percentiles take a lot of work to be able to kind of understand. You've probably seen percentiles like, oh, this is typical in height and weight. So as you were growing up, you probably went to the doctor and they say, oh, you're in the such and such percentile for height. Okay, mine tended to be a little bit on the higher end comparatively, but that's where the idea comes from. What it says is what percent of people or what percent of the data points are you above? Okay, so if you're in the 90th percentile, that means you're above 90% of the data. Okay, the easiest percentile to find is the 50th percentile. It's denoted P and then kind of subscript 50. That's half of the data below and half the data above, which is the median. Okay, so we already have some strategies to find that one. Okay, but the percentile is always denoted P and then sub whatever number. So P sub 2, like this one, is the 2nd percentile. P sub 99, the 99th percentile. Now you'll notice you'll never see a 100th percentile. The 99th percentile says you're in the top 1%, and there's 99% below you. But to be the P100, you have to be just literally better than everything. Okay, and normally with percentile ideas, we're looking for a range of data as opposed to just a specific data point. Okay, If you Google search finding percentiles and all these things, there's lots of ways to find it. Here's the assumption we're going to use for right now. To find the percentile, I figure out how many numbers are less than my number in the data set, divide by the total, so basically make that a decimal, and then multiply by 100, that'll be a percent. After that, I'm going to round to the nearest whole number. Okay, so let's go through that again. Wherever my number is in the data set, I find that spot, figure out how many numbers are less than it, divide by however many the total amount is, and times 100, and that will get me my percentile. So that's one version you might have to do. The second version is taking a percentile and converting it backwards to figure out, well, where's the cutoff for this? So whatever percentile you're trying to find, okay, let's say it's the 80th percentile. So this would be 80 over 100 times the number of data values. That does not give you the data value. That gives you the position of the data value. Okay, so that will find the spot. So if you get L equals 10, that's the 10th value. And no matter what, you always run around that number up. So when you're finding percentiles, you want to take the data set, or take the percentile, divide by 100 times the number of data points, then round that number up to give yourself a little bit of cushion. You want to guarantee you cover the spot, so you're going to give yourself a little bit of cushion. If, in fact, that number that you find is a whole number, you have to average that one and the next number. If you think about that, that makes sense, because that would be the idea of figuring out how to find the median. So if you were right in the middle and you had to average the two numbers, you'd have to add them up and divide by 2. That only happens if that position, when you find this, is a whole number. So let's go through a few example questions of this. Obviously, we're going to go through this probably multiple times because we need to practice it because it's new. The z-score piece is a little bit easier to work with, I think, once you get going with the formula. Percentiles take a little bit more work. Quartiles. There's 3 quartiles in a data set, denoted Q1, Q2, Q3. Okay, Q1 is the 25th percentile, Q2 is the median 50th percentile, and Q3 is the 75th percentile. The big thing from the quartiles that you're going to need is what's known as the interquartile range, or IQR. We're going to be using that for box plots here in the next lesson. And that's found by taking the third quartile minus the first quartile, okay, in the data set. A lot of data programs can find this for you. They kind of can find percentiles, but I want you to be comfortable being able to find those on your own with a smaller data set. But for quartiles, your calculations can typically be found using things like StatCrunch or some type of technology utility. So one thing you may need to know for StatCrunch is how to order numbers. Okay, if you haven't figured out how to do that yet, you go to Data, Sort, and select the column you want, and then hit Compute. You should be able to see the data, and then it's sorted from least to greatest, for example. That's going to be really helpful when you find things like the median and the percentiles in order to figure out how to find those answers. Okay, so here's a data set of test scores. So I've got 17 test scores that we're looking at. It says find the percentile of the test score of 75%. Well, the first thing you have to do is this doesn't help until I sort the data. So let's sort the data. So I used a graphing utility, sorted the data. Okay, here we go. Now it says find the percentile of the score of 75%. So here's 75% right here. In order to figure out the percentile, I figure out how many numbers are below 75. So I just count 1, 2, 3, 4, 5, 6, 7 numbers below 75 out of the 17 test scores. So I take 7 out of 17, number of pieces below my number divided by the total times 100. I get 41.18. Now for these pieces, it's less of an issue if you're rounding up or down. Just round to the nearest whole number, and that represents then the 41st percentile. So what you're saying is you're better than 41% of the people. Okay, so when you're finding that, you're just saying, all right, where's my cutoff? How many numbers less than mine? Divide by the total times 100, and that will find the percentile. The next question says find the 85th percentile. Like, what data value is it? So I'm going to I work backwards. I take 85 divided by 100, which is the percentile, make it a decimal out of 100, times the number of data points, which is 17. I'm going to get 14.45. Now remember, when we find the position, we have to round up to make sure we cover our bases. So when I round up to 15, that's the 15th number. That's not saying that your point is 15, it's the 15th number. So you just find the 15th number, which in this case is 91. So the 85th percentile is 91. Quartiles, one way to find the quartile is using your StatCrunch program or some type of utility. The other way is once you find the median, so 77 here is the median of this data. You'll notice there's 8 numbers below 77 and 8 numbers above. Okay, essentially what you want to do is cover up everything except these 8 numbers and say, okay, find the median of this data set. So if I were to find the median of this data set right here from 48 to 75, I would find the middle two, which would be 65 and 71, and basically do the median or the average of that. So I'd add those two up. In Q1, the first quartile is 68, excuse me, and then do the same thing with the upper half. This one's nice because they're both 87, so the third quartile is 87. Remember, from there I could find the IQR, the interquartile range, by taking Q3 minus Q1. In a test situation, it's either going to be a smaller amount of data where you can find the quartiles fairly quickly. Okay, remember the median, and then kind of cut it in half, and then just do the median of the lower half and the median of the upper half of data to find that. StatCrunch can also help as you're looking at your homework to find some of that information. Okay, main takeaways. You need to know how to find a z-score. Okay, so you want to make sure you practice that. You have to know how to find some percentiles. That's probably the hardest part of the whole lesson. And then we're going to use that information with IQR and things of that nature for our next lesson that's dealing with box plots. Have a good day, everyone.